Chapter 11.2, Part 2. We're now going to start working with the union symbol. And we could have used this symbol earlier on when we had our domain from negative infinity to 5, from negative 5 to 5, and 5 to infinity. What we had done earlier was we just separated each of those intervals with commas. It would be more appropriate to separate them with unions symbols. They mean that the domain or the input could have been in any one of those intervals. And you can use this U symbol in interval notation or set notation. I'm going to demonstrate below a few more ways that you can write domain, and a few of them will use this union symbol. This first one is a set of points, so it's not an interval. So I'm not going to write this one in interval notation. I will demonstrate it in set builder notation. That looks like this, the set of x such that x equals, and we'll just list the individual elements. You could also write it in set notation, and that's where you put the x on the outside of the set bracket and you describe the elements of x. With this next one, we have a point and then a range of x's that will work. So with this next one, I'll show you this one in set builder notation. X such that x could equal 3. Now instead of putting a comma, which would be fine, we could have also put a u and described the next interval. X is larger than or equal to 6. Great. Now what we can do is describe this next one in set notation. And with set notation, we'll say that x equals 3, just as a point. And then we will describe the interval from negative 6 to infinity. For this last one, we've got 2 intervals. And so we'll have from negative 1 to 0 and from 5 to infinity, not including 5. So in set builder notation, we'll have x such that x can be between. So we'll say x is greater than or equal to negative 1, less than or equal to 0, union, and we'll say x is larger than 5. In interval notation, we would describe the first interval, negative 1 to 0, and union with 5 to infinity. And we're using the inclusive brackets because we had closed circles, and we're using these parentheses because we had open circles. And sometimes your book will have, or your worksheets will have open circles, and sometimes they will use parentheses instead on the number line. So you should get used to both the parenthesis and the open circle meaning the same thing. And so we didn't do interval notation for that one. We didn't do set notation for this one over here, and that's okay. All right, there is one more way to see domain and range, and that is to look at a graph. And this is most often appropriate when you're trying to find the range of something. You often want to see a visual representation of what's going on. So in this one, we're going to describe the domain in interval notation and the range in interval notation. So the domain is the x's that are allowed. So our smallest x all the way to our largest x. And it is an open circle on both ends. So the interval notation for this will be x can be from negative 1 to 4. And we'll do the same thing for our range. And the range can go all the way up to 17, and it goes all the way down to 1. So from 1 to 17 And we're going to use an inclusive bracket for the 1 because it included the 1. We've got a filled in circle there, and we'll use an exclusive bracket for the 17 because it got really close to 17 but didn't equal 17, again because of that open circle at the top of the graph. All right, what's coming up next for you is your group work, where you'll be finding the domain and range of various functions, and I'm asking you to graph each of these, and we'll talk about that in class. Thank you. I will talk to you all soon.